If you've ever bought something, maybe a shirt or pants, and wondered why the seams just gave out after only like 3 washes.
Yeah, it's frustrating.
Exactly. Well, today we're aiming to give you the ultimate shortcut past just, checking for a loose thread. That visual check. It barely scratches the
Right.
surface.
We're taking you inside the labs, basically, where the real engineering happens, where true garment quality and durability are actually measured.
Because the critical stuff, how strong a seam really is, how long it'll last under stress, you just can't see that with the naked eye.
Completely invisible.
Yeah.
So our mission today is to cut through the usual marketing fluff and show you how manufacturers use these really rigorous standardized tests. It's all about ensuring durability. It's like this hidden engineering challenge sitting right there in your closet.
Okay, so let's unpack that. The research we looked at makes it really clear that quick visual check, maybe 10% of the story, tops.
If that.
Right. The real deep dive happens when engineers mix that quick look with some pretty intense lab analysis.
And that's how they move past just guessing how long something might last. It lets them pinpoint the actual weak spots, tweak the sewing parameters, optimize things to hit specific performance targets.
What's kind of amazing is just how much they test for. It's not just will it rip. They're looking at a whole bunch of different things.
Oh, absolutely.
Yeah.
Because garments fail in lots of ways, right?
Yeah.
So yeah, they test tearing strength, bursting strength, tensile strength, which is a whole category in itself.
Tensile strength covers things like what? Tension, breaking point.
Exactly.
Yeah.
Tension, the actual braking force, how much it stretches, that's elongation, and how well it bounces back, which is recovery.
And it goes even further than just brute force, doesn't it? The tests also look at stuff like yarn slippage.
Yeah, how resistant the stitching is to the fabric yarns actually sliding away from the seam. That's crucial.
Okay, and things like how well it holds up after washing, dimensional changes.
Whether the needle itself cause damage when stitching it, and just the overall strength of the finished stitch. It's this really comprehensive checklist.
The goal being that the seam should basically outlast the fabric itself.
Ideally, yes. Long, long after the fabric gives out. So let's maybe jump into the core methods, starting with the big one, seam strength testing. This is really the foundation.
Right, the main number. How much punishment can that seam actually take before it just pops?
It measures the raw force needed to completely break the seam.
Right.
That pop you mentioned when you bend over, that's this metric feeling you.
So how do they test that? Is there like a standard way?
There is. Most common is the grab test. It's standardized globally, very widely used. They cut a specific strip of fabric, center the seam, and then this machine, a tensile tester, basically a high-tech clamp, grips the fabric on either side.
Okay.
Then it just pulls, applies a constantly increasing force until, bang, the seam fails. That maximum force right at the breaking point. That's your seam strength value.
Okay, that makes total sense for pulling stress, like reaching up high or the strap on a bag. But hang on, if that's the standard, doesn't it miss other ways seams fail? What about pressure pushing out? Not along the seam line.
That's a really sharp point. And yes, it leads us right to the burst strength test. This was designed specifically to simulate that kind of localized, concentrated pressure.
Ah, okay. So not pulling it apart, but pushing through it.
Exactly. Instead of pulling from the sides, the machine measures the force it takes to push a special diaphragm, sort of like a blunt probe, through the fabric right at the seam.
So the grab test is like, will it survive being yanked? But the burst test is, can it handle pressure from inside pushing out? Or maybe something sharp pressing on it.
Precisely. Think about performance sportswear, right? Or maybe the seams in your car seats. Those need to resist pressure from your body, constant pushing. A garment could ace the grab test high tensile strength, but still fail miserably under burst pressure if the fibers around the stitch holes are weak.
So you need both.
For true quality, absolutely. You need to defend against both kinds of failure.
What's interesting, though, is that sudden catastrophic rip that's actually kind of rare in clothes that are made reasonably well, isn't it? Usually it's more gradual. The thing just starts to look bad, loses its shape.
That's often true. And it brings us neatly to the second critical area, seam slippage testing.
Slippage. Okay, what are we testing for here?
This looks at the stitching's resistance to, well, yarn slippage. That's when the fabric threads themselves start moving away from the stitch line when the seam is stressed.
And why should you care about that?
Because that is the #1 cause of clothes looking old before their time. You get seam puckering, little gaps appearing along the stitches, and eventually the whole seam just loses its integrity.
Okay, so it's not about a sudden break, but this slow creeping failure. How on earth do they measure that?
Primarily 2 ways. The first is called the fixed load method. They take a fabric strip with the seam, clamp it in, but instead of pulling till it breaks, they apply a constant load.
Constantly, just hanging a weight on it?
Pretty much, yeah. A weight that stresses the seam but doesn't break it outright. Then they measure how much the yarns slip within that seam over a set period.
Okay, that sounds like the test that really separates, fast fashion from something built to last. It's testing fatigue resistance.
Absolutely is. Then there's a more targeted technique. It's called the needle clamp method. This one's zeroes in on potential high stress points.
A needle. How's that different from the grab test again?
Well, here they clamp just a small section of the seam. Then they take this very specific calibrated needle-like probe and insert it right into the seam structure itself.
Okay.
And they measure the force needed to pull that needle through the seam, basically forcing the yarns apart.
Yeah.
That force tells you how resistant the yarns are to being locally pushed aside.
Wow, okay. I can see how that applies. You might not have a literal needle poking your shirt, but that force relates directly to stress from hardware, right? Like rivets in jeans or where a zipper meets the fabric.
Exactly that. Or big buttons. Any point where there's concentrated pressure. If it takes very little force to push that needle through, that spot is going to be vulnerable to separating under strain. It connects the micro-level yarn movement to real-world weak points.
So we've got strength, the breaking point, and slippage, the slow failure. But, let's be honest, how a garment looks often matters just as much, especially initially.
For sure. Which brings us to the third fundamental area, seam appearance testing.
Because even a technically strong seam can look, messy, puckered, or uneven.
Right. And that kills the perception of quality. Manufacturers need a way to measure appearance objectively, get past just someone eyeballing it.
But how do you get objective numbers for something like smoothness? That feels so subjective.
They use these amazing devices called seam smoothness testers. They're quite sophisticated. They don't just look. Often they use things like laser mapping or light refraction.
Laser mapping?
Yeah.
Serious?
Yeah, to basically create a topographical map of the seam surface.
Mm-hmm.
They measure all the little height variations, the tiny peaks and valleys along the stitch line. Then they digitize that data and assign an actual numerical grade for smoothness.
So you could literally see a spec sheet that says smoothness rating, 4.5 out of 5.
Precisely. And you'd know that seam was engineered for minimal puckering, setting it apart from cheaper construction where it might look more rippled. It connects that lab data directly to how flat and clean the seam looks and feels.
Okay, so we've covered the fundamentals, strength, slippage, appearance. But the source material really stresses that context is everything. The application matters. Not all seams need the same kind of resilience.
Exactly. This is where testing gets tailored to specific uses and stresses. Environmental factors become really important.
Like just doing the laundry. You mentioned washing resistance testing.
Yeah, and this isn't just about color fastness. They put seams through repeated, often quite harsh, simulated wash cycles.
And they're checking.
They're evaluating how well the seam holds on to its original strength and its appearance after all that washing. Does the stitch tension loosen up? Do the fibers swell unevenly and cause puckering? Does the whole seam shrink weirdly?
Right. And then for stuff that gets rubbed constantly, like backpacks, work pants.
For those, you need abrasion resistance testing. Think about jeans rubbing against a seatbelt or the shoulder straps on a heavy pack.
So they simulate that rubbing.
They do. These tests basically simulate years of friction in just a few hours, checking how well the seam, and crucially, the thread itself holds up to that constant wear and tear. It's vital for things like car seats, belt loops, anywhere there's continuous friction.
Okay. And then there's one more test mentioned, one that sounds like it has really high stakes, seam security testing.
Ah, yes. This one is absolutely critical. We're talking specialized gear here, safety harnesses, workwear for dangerous jobs, military kit, maybe even things like firefighter uniforms.
Stuff where failure is just not an option.
Not an option at all. This test isn't just about strength. It's about ensuring the seam maintains its complete structural integrity under its maximum designed load, or even potential overloads.
We should probably pause there because the context is so different, right? A seam failing on your t-shirt is annoying. A seam failing on a climbing harness.
Or a deep-sea diving suit, yeah. It's potentially life or death. The engineering rigor, the testing, it has to be on a completely different level.
So seam security ensures it holds reliably under extreme stress every single time. It's not just strong, it's secure.
Exactly. It's really the difference between industrial safety engineering and everyday apparel making.
Wow, okay. So, we've journeyed from the basic braking power in the grab test and the push-through pressure of the burst test,
Through the slow burn failure measured by slippage tests.
and into these really specialized high-stakes application tests like abrasion and security.
And just to give context, this knowledge is pulled together from research compiled for a really detailed seam catalog, focusing specifically on durability and quality. The source is a book called Strong Seams.
And the sheer range of tests available just hammers home that making a truly durable garment isn't guesswork, it's engineering. You have to defend against all these different ways a seam can fail.
Precisely.
So for you, the listener, understanding these categories, strength, slippage, appearance, security, that's the shortcut. You don't need the lab yourself, but knowing a manufacturer actually did the fixed load test for slippage or put their gear through seam security testing, that tells you way more about quality and lifespan than any tag or marketing slogan.
It really does. It gives you the language to understand what goes into making something properly.
It makes you appreciate the complexity behind what just looks like a simple line of thread. Which leads us to a final thought for you to maybe ponder. If this much science and engineering goes into just one seam, think about all the other everyday things we rely on. Your car tires, the chair you're sitting on right now. What unseen testing and quality control goes into those?
And maybe bring it back to your own wardrobe. Think about that one item. Maybe it's a heavy bag strap or that really worn seam on your oldest backpack. Knowing what we know now about seam security, about holding under maximum load, which piece of clothing or gear do you own that you suspect would absolutely fail the seam security test?
Something to think about. We'll leave you with that. Until next time on The Deep Dive.